On Tuesday night, while almost the entire world was watching Japan, the ground moved under Northern California. A magnitude 4.3 earthquake struck a few miles east of Cloverdale, in Sonoma County, about 26 miles northwest of Santa Rosa, followed by an aftershock. On its own, a 4.3 is not a disaster. People in San Francisco felt a light shudder. People in Ukiah felt it. Nothing collapsed, nobody was hurt, and by the next morning it had been almost completely buried in the news. Because 27 hours earlier, an earthquake in Kumamoto, Japan, had maxed out the Japanese intensity scale and killed dozens of people. Next to that, a 4.3 in the California wine country didn't stand a chance of anyone's attention. But I want to give it your attention for the next 20 minutes, because of where it happened. That quake was on a fault most Californians have never heard of. It's called the Maacama, and it does not have the fame of the San Andreas or the Hayward. It runs through a quiet stretch of vineyards and forested hills in the North Bay, largely out of sight, and most of the people living on top of it could not tell you its name. Here's the first thing that should make you sit up. This is the second time in 5 weeks that this obscure fault has shaken. Just over a month ago, on the 24th of June, a magnitude 5.6 struck the same fault zone near Ukiah, strong enough to crack walls and rattle an entire region. And now, 5 weeks later, the ground a little further south lets go again. And here's the second thing, the one that actually matters. The Maacama is not a standalone fault out in the countryside. According to the US Geological Survey, it is the northernmost segment of the Hayward fault system. And the Hayward fault is the one that runs directly under Oakland, Berkeley, and the most densely populated corridor of the East Bay. The fault that just shook the wine country twice in 5 weeks is the far end of the same structure that seismologists consider one of the most dangerous in America. This is not a video telling you the big one is coming this week. It almost certainly isn't. It's a video about the fault at the top of that system, a fault we know startlingly little about, suddenly making noise, and about the one thing in the coming days that will tell us which kind of sequence this actually is. I'm Adam Cross. If you want the real data and no invented drama, subscribe. We do this every week. And drop a comment right now. Did you feel this one? Where were you, and what did it feel like? A lot of you are sitting right on top of this, and I read every reply. Start with exactly what happened, because the timing is the whole reason you didn't hear about it. At around 7:45 on Tuesday evening, local time, a magnitude 4.3 earthquake struck roughly 8 kilometers east-southeast of Cloverdale, a small city at the northern edge of Sonoma County. The shaking reached down into San Francisco as a light, weak jolt and north to Ukiah, with the strongest shaking, naturally, closest to the epicenter. A magnitude 2.5 aftershock followed. The US Geological Survey logged it, the local Bay Area stations ran a quick breaking news item, and then the story essentially stopped. It stopped because of what had happened the day before, on the other side of the Pacific. On Tuesday afternoon Japan time, a powerful earthquake had struck Kumamoto Prefecture on the island of Kyushu, registering the very top of Japan's seismic intensity scale, collapsing part of a shopping mall, killing dozens, and triggering more than 100 aftershocks. That was, correctly, the earthquake story the world was following. So a moderate quake in the California countryside slipped through almost unnoticed. And that's a shame, not because the 4.3 was dangerous in itself, it wasn't, but because it was the latest signal from a fault that has been quietly speaking up for over a month, and that we have every reason to pay closer attention to. Because here is what makes the Maacama genuinely unusual among major California faults. We barely know it. The San Andreas has been studied for more than a century. We know when it ruptured in 1906, we know its long prehistoric record from trenches dug across it, we have a reasonable sense of its rhythm. The Hayward fault has been trenched, dated, and modeled exhaustively. We can put numbers on how often they produce big earthquakes. The Maacama is different. In the words of the Uskers, scientists still know relatively little about the Maacama fault's seismic history, or its earthquake cycle, which means, in their own framing, that it remains difficult to predict how often large earthquakes may occur on it in the future. Think about what that actually means. This is not a minor crack. It's a major fault running through Sonoma and Mendocino counties, near the towns of Ukiah and Willits, and it is capable of producing large earthquakes. And yet we don't have the clean, dated prehistoric record for it that we have for its more famous neighbors. In parts of Sonoma County, north of Healdsburg, the fault is physically obscured, buried under massive ancient landslides where it runs east of the Alexander Valley, which is part of why it's been so hard to read. There's one more feature that matters for what we're seeing now: the Maacama creeps. Along much of its length, the two sides of the fault slide slowly past each other, around 8 millimeters a year, roughly a third of an inch, without a big earthquake. Creep sounds reassuring, and in some ways it is. A fault that's creeping is releasing some of its strain gently. But creep does not mean safe. A creeping fault can still lock in patches, store strain in those locked sections, and release it suddenly. The steady creep is the background hum. The locked patches are where the earthquakes come from. So we have a large, capable fault, poorly understood, that creeps in some places and locks in others. And over the last 5 weeks, one of those patches has been letting go. Let me lay out the sequence, because 2 events in 5 weeks on a fault like this is what turns a shrug into a closer look. On the 24th of June, at 10 past 8 in the morning, a magnitude 5.6 earthquake struck near Ukiah, directly within the zone of seismicity that tracks the Maacama fault. It struck beneath a remote, forested stretch of mountains. As it happened, almost directly under a Buddhist monastery in otherwise empty country, which spared it from hitting a town directly. But seismometers close to the rupture recorded shaking in the range that can crack walls, break dishes, and partially damage more vulnerable buildings. A 5.6 is not a footnote. It's a real, damaging earthquake. Then, 5 weeks later, the July 28 magnitude 4.3 near Cloverdale, further south along the same fault system. Now, I want to be careful here, because this is exactly the point where the honest version and the hype version split. 2 earthquakes on the same fault zone in 5 weeks is not, by itself, proof of anything ominous. Faults produce clusters. A moderate earthquake is often followed by other moderate earthquakes in the same area as the crust adjusts. This could be nothing more than a fault working through a restless period and then going quiet. But it's worth knowing that the Maacama has a documented history of behaving in swarms, clusters of many small earthquakes without a single dominant shock. The USGS studied a swarm-like sequence on this exact fault back in 2020, in fine detail. So a burst of activity here is in character for the Maacama. The question is never whether it can produce a cluster, it's whether a given cluster stays small and fades, or whether it's the early part of something larger. And that question matters more here than it would almost anywhere else, because of what the Maacama is connected to. This is the part that turns a rural fault into a Bay Area story. The Maacama does not exist in isolation. Geologically, it is the northern extension of the Haywood-Rogers Creek fault system. The USGS describes it plainly as the northernmost segment of the Haywood Fault subsystem of the San Andreas Zone. Picture it as one long fault family running down the eastern side of San Francisco Bay, the Maacama at the top, up in Mendocino and Sonoma, handing off southward to the Rogers Creek Fault through the Santa Rosa area, which in turn connects to the Haywood Fault, and the Haywood runs directly beneath Oakland, Berkeley, San Leandro, Haywood, and Fremont. Some of the most densely populated ground in the entire state sits on top of the southern end of the same system, whose northern end just shook twice. And the Haywood Fault is not an abstract worry. It is often described as one of the most dangerous faults in the United States, precisely because it runs straight through a corridor of more than 2 million people, under old buildings, water lines, gas mains, and the infrastructure that ties the East Bay together. The USGS has modeled major ruptures on the Haywood-Rogers Creek system that reach into the mid-7s in magnitude, the kind of earthquake that would do catastrophic damage to the East Bay. Now, I have to be precise here, because this is where a lot of coverage overreaches, and I'm not going to. A magnitude 4.3 on the Maacama does not mean the Haywood is about to rupture. These faults are connected as a system, but they are also distinct segments, and a moderate quake at the northern end is not a trigger that reaches 100 miles south to Oakland. Anyone telling you this quake is a direct warning for the East Bay is selling you something the science doesn't support. What is true, and what's worth sitting with, is subtler and more honest. The fault that just produced 2 earthquakes in 5 weeks is the top of the same structure that carries the Bay Area's worst-case earthquake at its bottom. It's a reminder of where the danger in this region actually lives, not that the danger arrived on Tuesday night. Here's where I slow down and give you the honest odds, because this is the exact spot where a lot of channels swap the facts for a countdown clock. The overwhelming likelihood is that this sequence fades. The single most probable outcome, by a wide margin, is that the Maacama shakes for a while, produces a few more small to moderate quakes, and then goes quiet again, the way most earthquake sequences do. A 4.3 followed by a 2.5 is, statistically, most likely just a fault adjusting. The reason seismologists don't simply wave it off comes down to a problem that sits at the heart of earthquake science. And it's worth understanding because it explains why nobody can give you a clean answer. There is no test, in the moment, that can tell you whether a given earthquake is a standalone event, the main shock of a sequence, or a foreshock, a smaller quake that precedes a larger one. In the overwhelming majority of cases, a moderate quake is not a foreshock, but in a small percentage of cases, it is. And you can only ever tell the difference afterward by seeing what happens next. That's the genuine reason a 4.3 on an understudied fault, 5 weeks after a 5.6 on the same fault, gets a second look rather than a shrug. Not because it's a warning, because it sits in the small band of uncertainty where the honest answer is, we'll know more in a week. So let me give you the useful part, the specific things the people who study this are actually watching over the coming days, so you can read this the way they do instead of the way the panic feeds do. The first is magnitude. As long as the quakes stay small, in the 2s, 3s, and low 4s, this is a fault working through a restless stretch. If the sequence starts producing larger events, in the 5s, and especially if they climb rather than settle, that's the sign it's doing more than fading. The second is direction. And this is the one that matters most for this particular fault. Seismologists watch which way the sequence migrates along the fault. A cluster that stays put, or drifts north into the emptier country, is far less concerning than one that migrates south, towards Santa Rosa and the Rogers Creek Fault, because south is the direction of the cities and the direction of the connection to the Hayward. Movement toward the populated end of the system is the thing that would raise concern. Movement away from it is reassuring. The third is a formal advisory. If the USGS issues an official statement raising the probability of a larger earthquake in this zone, that's not routine. That's the professionals telling you, in plain terms, that the odds have measurably shifted. That's the moment to act on a plan rather than simply watch. Everything else, the viral clips, the countdown timers, the doom, is noise. Magnitude, direction, and an official advisory. Those 3 things are the entire dashboard. Let me be clear about the shape of this before we close. This is not connected to the earthquake in Japan. I know the timing invites the thought, but faults on opposite sides of the Pacific are not mechanically linked in the way that idea assumes. 2 large earthquakes in the same week, thousands of miles apart, on unrelated fault systems, is not a connection. It's arithmetic. The planet has thousands of earthquakes a day. Things that happen constantly will sometimes happen close together in time. It is not a prediction of the big one. Nobody can give you a date, and anyone who does is guessing or lying. What this is a moderate quake on an understudied fault that happens to sit at the top of a very dangerous system. And it is not something being hidden from you. Every fact in this video comes from the USGS and from published seismic research, in the open, on the record. If anyone had a reliable way to forecast a major earthquake, it would be the biggest story on Earth, and the people holding it would be famous, not silent. The real value here isn't fear, it's location. Most people in the Bay Area think of earthquake danger as the San Andreas, out to the west. But the Hayward system, running up the east side of the bay and reaching all the way north to this quiet fault in the wine country, is where an enormous share of the actual risk lives. And it just reminded us it's there, twice, in 5 weeks, while everyone was looking somewhere else. If you're in the North Bay or the East Bay, the takeaway isn't to be afraid tonight. It's to do the afternoon of preparation almost nobody does. Know where your gas shutoff is, and own the tool to turn it. Strap the water heater, and bolt the tall furniture to the wall, because in most earthquakes it's the contents of a building, not the building, that hurt people. Keep 2 weeks of water and food that needs no cooking. Have a plan for when the cell networks fail. None of it requires fear. It requires an afternoon. The Maacama has been there the whole time, creeping quietly under the vineyards, largely unstudied, connected to the fault under Oakland by a chain most people never think about. This week it spoke up. Almost certainly, it goes quiet again. But the people who understand this region don't look away when the top of that system starts to move. Not because tonight is the night, but because one day, somewhere on that chain, it will be. If this gave you a clearer picture of what's actually under Northern California, subscribe. We track this fault system closely, and if the sequence starts moving the wrong way, you'll hear about it here first. And leave that comment. Did you feel this one? Where were you? And what did it feel like? A lot of you live right on top of this, and I read every reply. I'm Adam Cross. Thanks for watching, and I'll see you in the next one.